This is the final project for IEOR 241. We are simulating the operations of a bakery using the Sigma software. Our model is based on the assumption of an exponential arrival rate for our customers. For orders, we're considering three types of products: bread, cookies, and cake. For the operations within our bakery, there are 5 distinct tasks. Task 0, mixing ingredients. Task 1, kneading dough. Task 2, shaping dough. Task 3, baking. Task 4, decorating. The following table provides an overview of our various products as well as the associated tasks and required times. For our production, we assume that 5% of all products will be faulty. Furthermore, we use IDs 1, 2, 3 and 4, 5, 6 to indicate that products are meant for collection in store and delivery subsequently. The following table provides an overview of the cost of each server. The cost of the delivery worker is 200. Here we provide a brief overview of our profitability calculations. Here you can see a snapshot of the operations underlying our model based on Sigma. Let's go ahead and look into the Sigma model in a bit more detail. At the Enter node, a new customer comes in. A new job is created and subsequently enters the system. Next, we are looking at 2 loops, an inner loop and an outer loop. The inner loop is responsible for the assignment of jobs as well as for the job sequence. The outer loop determines the activity of the various servers inside the system. If at any given time there is no server available, the order will join the queue node. Subsequently, as servers become available, the order will move from there. Once an individual order is complete, it will move to the Assess node. Here we determine whether or not this order will be part of the 5% of bad production that we are assuming. At the second Assess node, we determine whether an order is for delivery or for pickup in the store. If no delivery worker is available at a given time, the number of orders ready for delivery will pile up. As soon as a delivery worker becomes available, he will work on that pile of waiting orders in batches of 4. We have been using the Java SDK to create an interface for our Sigma model. The interface allows the user to determine the number of individual servers as well as the number of delivery workers. We then create a .exp file which we pass on to the Sigma model. We're calling the Sigma model from within our Java interface, and we are creating a txt file with the output data. Finally, we can read in that output data to show the final results to the user.
And I will go ahead and briefly demonstrate the Sigma model we built in action. We have the model here. I will run it. And it provides us with the user interface, and we can now determine the numbers for the individual servers that we want to simulate. can also determine the number of delivery workers. I'll go ahead and confirm this. And here we see the output that was created by the Sigma model that was called from within this Java-based interface that passed these numbers through an external file to the Sigma model, ran the Sigma model, and reread these data items from another external file.